What we're going to do today is we're going to be solving quadratics using square roots. Last section we had done is we solved quadratics using factoring, and looking at some of these expressions we really don't know how we can go about factoring these, so we have a new technique, which is to use square roots. These equations, at least the first part of them, you really want to get x by itself, which is very similar to what you guys have done back in Algebra 1 and even before that when you had solved equations. We're trying to isolate the variable as much as we can before we have to do anything with square roots. So if I take a look at this first equation, I have 2x squared plus 1 equals 17. The first thing I want to do, try to isolate the variable. To do that, I could subtract 1 from each side first. If I were to do that, I would have 2x squared equals 16. And really from here, I would apply another Algebra 1 technique where I can just go through and divide each side by 2 in the attempt to isolate x and get it by itself. Now I get to this point, I have x squared equals 8, and really from here this is when the new technique takes over, because at this point I really wouldn't know how to solve this. If I divide by 2, that's not going to help me out because I would have x squared over 2. I need to get rid of the square on the top, and to go ahead and do that, what I end up doing is I take the square root of each side. Square root in our quadratic, those are going to end up canceling one another out, and that's something that we had talked about in class. So what that ends up giving us on the left hand side is just x, and that's going to end up equaling plus or minus the square root of 8. We have to address the plus or the minus, because if I square positive square root of 8, I get 8, but if I square negative square root of 8, I'm also going to get positive 8, so I have to look at both solutions. Now from here what I could do is I could try to see, can I reduce square root of 8? And I can. What I can end up breaking this down into is 4 times 2, and using my square root properties, I can end up saying, as I go through and I reduce this, I could split those into the square root of 4 times the square root of 2, and I could say this is going to end up reducing to positive or plus or minus 2 times the square root of 2. And those would be both of my answers. If I plugged in either of those to my original equation, then I would get a true statement, which is really what I'm looking for. What x values are going to give me a true statement when I look at these equations. On the other side, same sort of approach. I want to get x by itself before I go through and I do anything. And the first thing really here what I can do is divide each side by 3 in the attempt to isolate the variable. I would have x minus 2 squared equals 7. And now really from here my new technique takes over, where I end up taking the square root of each side. So at this point, take the square root on the left, square root on the right, and as we had seen, the square root and my squared sign cancel one another out, so really all I'm left with would be x minus 2, and that's going to equal plus or minus the square root of 7. Remember, it's going to be plus or minus the square root of 7, because if I say, take a look at it down here, negative square root of 7, and I square that, I say negative square root of 7 times negative square root of 7, the negative times the negative, oh, can't even see it, negative times the negative is going to give me a positive, and then by my rules, or my square root properties, I would multiply the contents between those two, and I have a square root of 49, which ends up giving me 7. But I would really get the same exact answer if I went through and I did this, just square root of 7 times square root of 7. So just need to address that again. That's something we had gone over in class. But from this point now, what I do, I want to get x by itself. I add 2 to each side. The x is left alone on the left hand side. Now on the right hand side, what I'm left with is 2 plus or minus the square root of 7. The 2 goes in the front. It is not combined with this plus or minus square root of 7. So what that's telling me is I could have 2 plus the square root of 7 or 2 minus the square root of 7. And both of those numbers are going to end up giving me a true statement in this original equation. If I plug in either of those answers into the equation, I would get a true statement.